Good morning, students. Today we are going to discuss another topic, that is laws of refraction. In reflection, we have learned two laws, that the incident ray, reflected ray and the normal at the point of incidence all lie in the same plane. That was the first law. And the second law of reflection was the angle of incidence is always equal to angle of reflection. Now in refraction also we have two laws. So you must open page 174 NCERT book, and just in the beginning you go through the laws, must learn it. The first law says that the incident ray, the refracted ray, here incident ray is AO, refracted ray is OB, and the normal at the interface of two media. Here is the interface of two media. The first media is air and the second medium is glass. So at this interface, that means at point O, all lie in the same plane. And the second law, that is very important and also known as Snell's law, is the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media and for a given color of light. And that's why we have written, if I is the angle of incidence and R is the angle of refraction, then we can write sine I by sine R is equal to constant. So this ratio, if you make a in trigonometry you have learned the trigonometrical ratios, sine theta, cos theta, tan theta, like this. So in this, if we take sine of angle of incidence and sine of angle of refraction, then this ratio is constant for a given pair. Here the pair is air glass, so it will be different for air water. So for a given pair of media and for a given color of light, this ratio is always constant, and this is known as Snell's law. Now we will define a very important term after that, that is refractive index, because this constant is equal to refractive index of second medium with respect to first medium. Here we have written sine I by sine R is equal to a constant. Now this constant is equal to refractive index of second medium. Second medium is glass. It means this constant is equal to refractive index of glass with respect to medium 1, that is air. Now what is refractive index? So next important topic is refractive index. Refractive index. In short, we can write Ri also, R dot I dot, and the symbol we will use as given in NCERT book, that is we are representing refractive index by this small letter n. So what the refractive index is? As we know, when a ray of light passes from rarer medium to denser medium, for example, ray of light is passing from air to glass. So air is the rarer medium and glass is the denser medium. So it bends towards the normal, isn't it? The actual path of this light is like this. It will move in a straight line path, but the red dotted line shows the straight line path of light, but it deviates from its original path. Why it deviates? Due to change in speed. So the extent of deviation that take place for a given pair of media is expressed in terms of refractive index. That how much a light deviate from its original path, from its straight line path in a given pair of media, that can be expressed in terms of refractive index. So you write this line, right? In refractive index you write the extent of the change, extent of the change of the change in direction that takes place in a given pair of media is expressed in terms of refractive index. Now we can relate a refractive index with an important physical quantity. That we have seen that a ray of light is deviate from its original path due to change in its speed. It deviate. So we can relate refractive index with speed of light in two media, isn't it? So let us derive an expression for it. Expression for a refractive index. Right. You will draw this figure and write down. Considering a ray of light is traveling from medium 1 into medium 2 as shown in figure. Let V1 be the speed of light in medium 1 and V2 be the speed of light in medium 2. The refractive index, of medium 2, with respect to medium 1, is given by the ratio of speed of light in medium 2 with respect to medium 1. So we can write the symbol for refractive index. The symbol for refractive index is N. Now we are writing N to 1. What is meaning of N to 1? It means N to 1 stands for refractive index of medium 2. Medium 2 is glass with respect to medium 1, that is air. with respect to W dot R dot T dot, isn't it? So meaning of N21 is refractive index of medium 2 with respect to medium 1, that is air. Now we can relate this with speed of light into medium. So it will be equal to speed of light in medium 1 by speed of light in medium 2. Now we have assumed that the speed of light in medium 1 is how much? V1. So or we can write or N21 is equal to V1 and speed of light in medium 2 is V2. So this can be written as N21 is equal to V1 by V2. Be careful that when we are taking here 2 first, it means when we are calculating refractive index of glass with respect to air, then we will take in numerator we are taking just opposite, speed of light in air divided by speed of light in glass. Now if you have to calculate N12, so what is the meaning of N12? It means refractive index of air with respect to glass. So here we have speed of light in glass by speed of light in air, just opposite. If you are calculating refractive index, if you are calculating refractive index of air with respect to glass, then in numerator you have to take speed of light in glass first divided by speed of light in air. Now there is a concept of absolute refractive index. Absolute refractive index, you can get a question what do you mean by absolute refractive index. So whenever we are calculating refractive index of another medium, or you can say a medium 2 with respect to vacuum or air, then that refractive index is known as absolute refractive index. What I am saying, whenever you are calculating refractive index of a medium with respect to vacuum or air, isn't it? Suppose we are calculating refractive index of glass with respect to air, then it will be absolute refractive index. Suppose you are calculating refractive index of water with respect to air or vacuum, then it will be absolute refractive index. So let us write a definition for absolute refractive index also. Absolute refractive index. Right. If medium 1 is vacuum or air, if medium 1 is vacuum or air, then the refractive index of medium 2, is considered with respect to vacuum, is considered with respect to vacuum. This is called absolute refractive index. This is called absolute refractive index. Now there is a general formula to calculate a refractive index of a medium. A refractive index of a medium. So the refractive index of a medium, we are writing Nm. Nm means N stands for refractive index of a medium. In general, it will be equal to speed of light in air by speed of light in medium, whatever be the medium. So it can be written as Nm is equal to speed of light in air or vacuum. You can also write vacuum. So we represent it by letter C, and speed of light in medium is V. Now C is fixed. As you know, speed of light in vacuum is 3 into 10 to the power 8 meter per second. So you will get so many numericals based on this formula also. So this is equation 3, that refractive index of a medium is equal to the ratio of speed of light in air or vacuum by speed of light in medium. If we represent speed of light in air by letter C and speed of light in medium by letter V, then we can write Nm is equal to C by V, and C is always fixed. You must remember it, that is speed of light in air or in vacuum is 3 into 10 to the power 8 meter per second. Now in your book, in table 10.3, some of the refractive index of materials are given. You see the materials are air, ice, water, alcohol, kerosene, fused quartz, turpentine oil, benzene, crown glass. This is table 10.3. Their refractive index are also given. And you see air has a minimum refractive index. Air has 1.003, so generally we take 1 roughly, and for glass it is about 1.5. These are the type of glass, that crown glass or Canada blossom. So roughly 1.5 the refractive index of glass, and diamond has highest refractive index. The refractive index of diamond is 2.42, isn't it? Now I think it is clear what the refractive index is, and I'm giving some questions. Page 176. Page 176. Question number 1 to 5. Obviously NCERT. You will solve all these questions, isn't it? And you will positively submit it on Saturday 7 p.m. Submit on Saturday 7 p.m. Because students are very good. They are not all are not sending their homeworks. You must labor hard. This is class 10, and you have to appear in board examination. You must be regular and try to understand the facts. You can call me. You can clear your doubts also. Try to solve these questions. So must submit your homework on Saturday 7 p.m. and all the questions, question number 1 to 5, and I think you can solve it. In next class we will learn about lenses. That is another important topic. Till then, and one thing more, yes, I want to tell you the syllabus for unit test. Unit test, you must learn from beginning. So it is for unit test, syllabus for unit test. Unit test 1, page 160 to page 171. Isn't it? I am not giving questions through refraction through a rectangular glass slab and the other topics up to refraction of light. Page 171, and the types of questions are, you will get MCQ questions, one word answer questions, and few fill in the blanks. Total 10 questions you will get in physics, 10 in physics, 10 in chemistry, and 10 in bio. Okay, so labor hard and try to score good marks, and must go through this topic and try to solve these questions 1 to 5. Okay.